Our new topic today is talking about centroids and moment of inertia. In a different title, it's section properties. And these properties will be centroid and will be something called moment of inertia. What do you mean? What is the meaning? Let me explain it in more details. Guys, we have something in our building, in our construction called beam. This beam probably take many different shape. Probably your beam looks like I-beam, like this, or channel like this, or HSS like this, or rectangular shape, or T shape, or inverted T, or L shape, or something looks like this, or like this, or like this, or like this. Just to make it easy for you, in the construction of any building, we construct something called beam. This beam in the real life is supported by columns. We have beam and we have column. And this column is supported by foundation, which is footing. If you would like to construct a building, you will construct first footing, then a column, then a beam, then the floor slab. I don't care about all of this stuff. My concern is this beam. This beam, in this case, looks like this in the 3D. If you decided to make cut in this beam, I believe the cross section looks like rectangle. That makes sense? Probably your beam looks like this in different cases. Your beam looks like this. If you watch around you, probably you can find this shape of beams. I believe if you make cut in this beam and look to the cut or look to side view of this beam, the shape looks like I shape, like this. Sometimes your beam looks like this. So which shape I'm gonna use, it's not our topic. I'm trying to explain something. Probably you have a beam looks like this. If you did a cut for this beam and watch side view, the cross section or the shape of cut looks like this. These shapes called cross section. Cross section means you have isometric, you have a body, and you did cut, and you are looking to this cut. The shape of this cut called cross section. This cross section depends on what is the shape of the isometric of the beam. In this case, looks like I shape. In this case, looks like channel. In this case, looks like hollow rectangle. This shape looks like rectangle. This shape looks like something like this. But I will give you a shape like this. But you need to understand this shape. What is the meaning of this shape? This shape in the real life looks like a beam. In the isometric shape looks like this. What I did is I did cut, and look to this cut, the shape of the cross section looks like inverted T shape. I know some of you will ask me, what is the main purpose of all of this stuff? I'm looking for what is the section properties. Already you have a cross section. This section has properties. We need to figure out these properties. That makes sense? Any questions so far? If you have any question, let me know. The first properties is centroid. As you know, guys, we are living on the earth. Earth has centroid. If you are talking about square, square has centroid. If you are talking about rectangle, rectangle has centroid. Any shape in this world has centroid. So the first properties, we need to understand something called centroid. Centroid is the central point of a figure and is also called geometric center. It is the point that matches to the center of gravity of a shape. Yeah, we understand all of this stuff. We understand what is the meaning of centroid. It's not a big deal. No, it's a big deal. Why? I will let you know. If you have rectangle, all of us, centroid at the midpoint, at the middle. Probably some of you, if you have right angle triangle, the centroid is here at 1/3 of the base and 1/3 of the height. This point is very important. Please pay attention. If you have right angle triangle, it should be right angle triangle. This distance called base. This distance called height. If you need to figure out where is the centroid of this right angle triangle, looks like here. At a distance from this side equal 1/3 of this base. And a distance from this side equal 1/3 from this height. If you have right angle triangle. If you have a circle, the centroid of a circle at this point, at the middle of the circle. Okay, we understand all of this stuff. Another properties. Do you know area? Yeah, this area, we learned this in the middle school. Area of rectangle is B times H. Length times width. Area of right angle triangle have base time height. Okay, area of circle by r square or by divide for diameter square. Yeah, all of this stuff, it's easy. They are easy. Centroid of rectangle, centroid of right angle triangle, centroid of a circle, looks good. Area of rectangle, area of triangle, area of a circle, looks good. But sometimes the cross section of the beam looks like this. Yeah, we have a beam. This beam in the real life looks like this. And we did cut. This cut looks like this. My question is, can you tell me where is the centroid? What is the area of this shape? I will ask you another question. Do you think this shape, which looks like this, do you think this shape looks like rectangle alone? Looks like right angle triangle alone? Looks like a circle? No. This shape is not one of these shapes. So how can I figure out the centroid? I need a point which you call centroid of this shape. Can you tell me where is this point? Okay, I know this shape looks different, looks weird for me, but I can divide it to right angle triangle and the rectangle and have a circle. So I divided my cross section to different parts. These parts probably rectangle, probably triangle, probably circle, or a part of a circle. So in our problems in this topic, I will not give you this easy shape rectangle or this right angle triangle or this circle. No, I will give you a complicated cross section. But this complicated cross section can be divided to many parts. These parts will be one of these three shapes. Okay, I understand this point, and that makes sense for me. But this right angle triangle alone has this centroid. And this rectangle alone has this centroid. And this semicircle alone has this centroid. I'm not looking for centroid for each part. I'm looking for where is the centroid for this cross section as a whole area. Where? You didn't answer my question. If you are looking for composite area, composite means area divided to many parts. So we have composite area, composite of different parts. We will look to the centroid x bar and y bar by this expression and this expression. Summation area times x divides summation area. Summation area times y divides summation area. This equation and this equation will help you to find the centroid. At this moment, I need you to understand 2 points. The first point, I will give you an area, a shape This shape in the real life, it's isometric. Something in a real life looks like beam. And I did cut for this beam, and I found the shape of the cut looks like this shape or this shape or this shape, whatever the shape. Then this shape can be called section or cross section. I'm looking for the section properties. What are the properties of this section? The first properties is centroid. And I understand centroid means central point, geometric center, or center of gravity. Where is the centroid? Where is the central point of this shape? If your shape is very simple, looks like rectangle, the centroid will be at this point. If your cross section or your shape looks like right angle triangle, it will be at this point. If your shape looks like circle, it will be at this point. But sometimes your shape looks like different parts combined together. So I'm going to use this and this equation to figure out the centroid. Any questions so far? Any questions so far? Okay. Okay, wait a moment, Mitchell, because a semicircle has a different technique. Example number 1. We have a cross section. Looks like inverted T shape. Can you locate the centroid of this shape? One more time. This shape in the real life looks like this. Probably you can find this shape in any construction because inverted beam at the roof or something like this. Anyway, and I did cut. The shape of the cross section looks like this. So I give you this shape. And I'm looking for section properties. The first properties I'm looking for, where is the centroid? Because this shape as a whole shape is not rectangle. To say the centroid at midpoint or at the middle. This shape as a whole, it not looks like right angle triangle. It's not like a circle. So I need to figure out where is the centroid. I'm gonna use this expression and this expression to figure it out. We have some steps. First step, divide this shape to small parts, and the small parts should be rectangle, right angle triangle, or a circle. Please divide this shape to small parts. These small parts must be one of these parts, rectangle or right angle triangle or a circle. What do you think? I believe if you divide this shape, I will divide it like this. This rectangle and this rectangle. Do you agree? Any shape for this one, for example, first step, you need to divide this shape to different parts. I believe I will divide it to right angle triangle, this rectangle, and this rectangle. Do you agree? Any shape I will give you, you can divide it to four parts. Each part can be rectangle, triangle, circle, or a part of a circle. Any question so far? Yes, all the time. All the time, David. Any shape, whatever the shape, you can split it to different parts, small parts. And believe me, the small parts will be one of these: rectangle or triangle, right angle triangle, or circle. Any question? I think the centroid of this rectangle is known at the middle for this rectangle only. And the centroid for this rectangle is known at the middle for this rectangle. I'm not looking for this one or this one. I'm looking for the centroid for the whole shape. We don't have curve. In this course, we don't have a curve. Curve, we need to go back to mathematics because we will do integration. We will not cover this point in this course. Your parts must be circle or right angle triangle or rectangle. We don't have a curve. For curve is very complicated. Okay, second step. Look to or look for references. I will choose the lowest edge of this cross section as reference number 1 and the farthest left side as reference number 2. So I'm gonna assume this one is X bar and this one is Y bar. Look for references. X bar axis at the lowest edge. Y bar axis at the left edge. For this example, where are your reference? I'm gonna assume this is the X bar reference at the lower edge. Where is the Y bar reference? Will be at the left edge, the farthest edge from left, Y bar. By the way, I can look out to this centroid for this right angle triangle, the centroid for this rectangle, the centroid for this rectangle. Any questions so far? First step, go ahead and divide. Second step, we are looking for references. At the lowest edge from the bottom, at the left side, I can locate the two references. Then I will construct this table. Number, area, X bar, area. time x bar. Let's see. How many parts do you have? How many parts did you divide this cross section? Part number 1, part number 2. So we have part number 1 and part number 2. Can you tell me what is the area for part number 1? What is the area of this rectangle? What is the area? 2 times 9, 18. What is the area of part number 2? What is the area of this rectangle? It's 3 times 6, 18 also. Any questions so far? Any questions so far? Okay. X bar. Go back to part number 1. This centroid has distance x from this reference. How much? What is the value of this x bar? What is the value? 4.5, I believe. For second part, what is the horizontal distance from your reference, your assumed reference? What is the value for this centroid, the horizontal distance? I believe 4.5 also. Can you use your calculator and multiply this column by this column? Yeah, go ahead. 18 times 4.5. This value will be 81. This value will be 81. Do you have any other parts? No, we have only 2. Okay, go ahead and get the summation for this column and the summation for this column. 18 plus 18, 36. 81 plus 81, 162. Guys, do you know what is the meaning of this number? This number means summation area. This number means summation area times x bar. Can you go back to this expression and say x bar for the centroid you are looking for will be summation area x bar divide summation area. I believe I found them. Summation area x bar 162. Summation area 36. If you divide 162 divide 36, your number will be 4.5. Wait a moment. Wait a moment. I will extend this table to y bar and the area time y bar. Guys, go back to part number 1. What is the distance y between this centroid and your reference? Do you know what is the vertical distance y bar? I think this distance between the centroid of part number 1 and the reference, you assumed this vertical distance will be 1 inch. Part number 2, what is the vertical distance between this reference and the centroid of part number 2, what is the vertical distance? Can you tell me? What is the vertical distance between this centroid of part number 2 and the reference you assumed at the lower edge? I believe this vertical distance will be 5. Do you have any comment? Go ahead and multiply this area times this y. It will be 18. This area times this y, 5 times 18, 90. Go ahead and get the summation of this column. 18 plus 90 will be 180. I think this expression will be summation area y bar. So y bar from this expression equal to summation area y bar divide summation area. Summation area y bar is 108. Summation area, you got it before, 36. So this value will be 3 inch. What does it mean? I'm gonna clean up all of this mess to explain something very important. That means from this origin, which is the intersection of this reference and this reference, I will do the following. I will walk in the x direction 4.5 horizontally. And I will walk vertically y bar 3 to reach to this point. This point will be the centroid of this shape. I walked horizontally 4.5 and I walked vertically 3 inch and I located the centroid. This centroid is the centroid for the whole section. Just to remind you, the centroid for part number 1 was here, the centroid for part number 2 was here, but the centroid for the whole cross section is here. One more time. One more time. Example number 2. First step, divide the given cross section to small parts. Believe me, the small parts must be rectangle, triangle, or a circle. Second step, locate references. The horizontal reference will be at the lower edge. The vertical reference will be at the left edge, the farthest left edge. Here is the origin. Third step, so we have part number 1, part number 2, part number 3. The third step, we need to set up a table. First column, number. We have 3 parts. So we have part number 1, part number 2, part number 3. The second column, what is the area of each part? Okay, go ahead and tell me. What is the area of part number 1? It's right angle triangle. So part number 1, the area will be 1/2 times 3 times 3. If you have a comment, let me know. 4.5. For part number 2, it's a rectangle. The area is 2 times 3 will be 6. Part number 3, it's a small square. The area will be 1 times 1 will be 1. So 4.5, 6, and 1. Can you get the summation for this area, yeah, I can tell you 4.5 plus 6 plus 1 will be 11.5. Third column, X bar. Guys, can you tell me what is the horizontal distance? Because X is horizontal. That makes sense? You are looking for distance X. Distance X means horizontal distance. So can you tell me what is the horizontal distance between this centroid and your assumed reference? What is the horizontal distance? Anybody can tell me? I need number. Guys, are you still here? What is the horizontal distance between the centroid of part number 1 and your assumed reference? I'm looking for horizontal distance because X bar is a horizontal. So what is the horizontal distance? 4 meter, 3 plus 1/3. No, you didn't get me. Guys, when I told you if you have right angle triangle, I told you this distance is called base. I told you the centroid is a distance. I didn't say 1/3. I didn't say this. I said 1/3 time base. I said time 1/3 time base. So if this base equals 3 meters, this horizontal distance will be 1/3 times 3 will be 1 meter. If this horizontal distance is 5 meters, this horizontal distance will be 1/3 times 5. That makes sense? So this little distance is 1/3 times 3. And we have 2 meters and 1 meter, so the total distance will be 3 meters. Okay, thank you. Thank you, Bortana. Thank you, Jordan. Thank you. But that makes sense? Okay. Second part. What is the horizontal distance between this centroid of the second part and your reference? What is the horizontal distance? I believe it will be 2 meters. Third part, what is the horizontal distance between this centroid and your reference? I believe this distance will be 0.5. Go ahead and set up the third column. Area times X bar. Multiply this column by this column. Just math calculation. 4.5 times 3 equals 13.5. 12.5. Go ahead and get the summation for all of this number. 26. So this summation will be summation area X bar. Keep walking. What is the distance Y bar? And what is the area times Y bar? One more time. Guys, if I'm talking about Y distance, so Y is a vertical distance. Let's go back to part number 1. What is the vertical distance between this centroid and your reference? What is the vertical distance? Do you remember? I told you the vertical distance is 1/3 times height. So please go back and see what is the height of this right angle triangle. Then this little distance will be 1/3 times this height. I believe the height of this right angle triangle is 3. So 1/3 times 3 will be 1 meter. So the vertical distance is 1. Part number 2. Here is the centroid. Can you tell me what is the vertical distance between this centroid and your reference? It should be 1.5. Part number 3. What is the vertical distance between this centroid for part number 3 and your reference? Vertical distance will be 0.5. Go ahead and multiply this column by this column. So 4.5, 9.5. The summation will be 14. 14? Yes. This summation will be summation area y bar. If you are looking for centroid, okay, x bar for the centroid will be summation area x bar divide summation area. 26 divide 11.5. If you are looking for y bar, it will be summation area y bar divide summation area. Summation area y bar is 14. Divide summation area 11.5. What is the number here and what is the number here? This one is 2.3 and this one is 1.2. That means I will clean up all of these things. Where is the origin of your reference? I assumed this reference and this reference. So here is the origin. Please start from this origin. I will walk horizontally 2.3. It looks like here. And I will walk up 1.2. So I walked here 2.3. I walked up 1.2 until I reach to this point. This point will be the centroid of this whole shape. Just to remind you, the centroid for this triangle is here. The centroid for this rectangle was here. The centroid for this little square is here. But the centroid for the whole section as a whole part is here. So please make sure you can understand this table, because this table is a piece of cake. It's very, very fun. The only part or the only two columns you need to pay attention when you are trying to figure out the distance x bar and the distance y bar. Anything else is nothing. Do you have any question? I'm not sure what you are talking about, Mitchell. This distance in the green color is 3 meters. That's right. 2 plus 1. And we have another little distance here, which is 1/3 times 3. So we have 1 meter. So the distance between this point and the horizontal distance will be 4. That's right. Oh, I have a mistake here. I'm sorry. You are talking about this part. So 3 plus 1 is 4. I'm sorry. Thank you. Thank you. It's my mistake. So it will make a big difference. Thank you. 4.5 times 4, 18 plus 12 plus 0.5, 30.5 divide 11.5 is 2.65. Thank you.